So this time I'm going to go through graphing the sine function a lot faster because we just did it. So on the same set of axes here, we're going to go ahead and graph sine x and y equals 2 sine x. We're going to go ahead and just graph one period of this. On the x-axis, this is going to be
radians.
X in radians. And then on the y-axis, this is going to be our function values. Now, I'm not actually going to specify sine versus 2 sine because I'm going to have two different functions going on here. So I'm going to have two different y values going on for every x coordinate. So what is the period of the sine function? 2 pi. I'm going to break it into how many equal parts?
4.
And I'm going to count by?
Pi, half pi.
Half of pi, pi over 2. Here we go. Pi over 2. Pi. 3 pi over 2.
3 2's a pi.
2 pi. For the sine function, so I'm going to make a little key for myself here. So in the darker color, that's just going to be the parent function, sine x. It's okay. Make it work.
Oh, and then you use your other color.
And then I'm going to come in with a second color to graph my second function. So for the first one, sine x, at 0, my first ordered pair should be what? 0, 0. At pi over 2, sine has a function value of 1. So at pi over 2, I'm going to plot a y value of 1. At pi,
Intercept.
it's an intercept, followed by my minimum, followed by
An intercept.
intercept. Get your curve going on.
Oh, mine looks like a V.
All right, next up,
Spread it out.
in red, I'm going to graph the function 2 times sine x.
What is that?
We will discuss that in just a second. So, if I want to evaluate, so I need to know what is the y value at 0. So, using my function right here, I want to know what is y when x is 0. So just like you've done so many times in your math careers here, we're going to plug in 0 for x and solve for y. If you evaluate sine of 0, you get 0. But there's a 2 there. So we have 2 times 0. In this situation, however, it doesn't change the end result. So when x is 0, y is 0. So I will plot another point on top of my original 0, 0. Followed by, now I need the y value at pi over 2. So plugging in an x value, notice how my x values in this situation are my radian measures. So plugging in my x value of pi over 2 will give me 2 from my function, so 2 times sine x, times evaluating sine of pi over 2 from our unit circle is going to give me 1. And multiplying 2 times 1 is 2. So now the y value at pi over 2 is 2.
Are we going to go over 2? Because I don't know.
And then it repeats.
And then it repeats. Okay,
Now drop it
so
off.
if you wanted to, you could keep on doing this, absolutely. So now you could do 2 times sine at pi, 2 times sine of 3 pi over 2, 2 times sine at 2 pi. Or you can take advantage of the cyclical nature of this function and say, all right, I know I started an intercept. Now that I know where my maximum is going to occur, I know that the next point I will plot will be an intercept for the sine function, followed by a minimum.
That's just.
Now the minimum will be -2.
Where did you get 2 from?
It was given to you in the function at the very beginning.
No, like, you had pi over 2.
What is
But
sine of pi over 2? What is sine of pi over 2? What is the y coordinate at pi over 2? Because sine is y coordinate from your unit circle.
Oh.
Thinking at the top of your unit circle, what is the y value? That's where this guy came from. Okay?
So technically,
And then finishing up.
when you do that with a different one,
Uh-huh.
you're gonna have to multiply it by radians, by radicals and stuff.
Yes.
Oh.
It'll be awesome.
I gotta work on graphing.
You will get better.
No, I mean, like, curvature.
Yes, I know what you meant. Well, I figured that's what you meant. All right. This brings up the final thing we're going to cover today. The difference between these two functions lies in something called the amplitude. So the reason that this function's max value is at 1 and this one is at 2 is because these two functions have two different amplitudes. So the...
Amplified them.
We sure did. The amplitude of your sine or cosine function, formally, we would define it as half the distance between the minimum and the maximum values of your function. So the minimum of your 2 sine x function, so the guy in red, is at -2. The maximum is at +2. This distance, the total distance of separation between min and max would be 4. So half the distance is what we would call the amplitude. So for this function, this represents my amplitude, and in this context it would be 2. For the parent function, so for just regular sine x, this one has an amplitude of 1. Now you can see this from looking at the function, the equation. So when I give you an equation, you shouldn't have to graph this to answer the question. If I just simply asked you, and I will, what is the amplitude of the function y equals 2 sine x? You can look.
Oh, it's like the A.
It is exactly the A. The exact same impact of A in any other standard form parent function equation that we've ever worked with is going to be the same impact that A will have on our sine and cosine function. Notice that a +2, if we put 2 in front of x squared, we would have ended up with a narrower parabola. So now it's just that, it's like I vertically have kind of scaled up my sine function. So the number in front of, or the A value in front of your trig function gives you your amplitude. So from that, A equals 2, therefore your amplitude is 2.
Why do we have to know it as a formula of like half of minimum and max?
Well,
you can just look at axis, from the
I love that
x-axis.
you asked that question because we will not always have a sine and cosine function that is situated in a way where it is repeating over the x-axis. So we can have vertical shifts up and down, just like we've shifted any function. So if I shift this up 5 units, all of a sudden you can't just look at the distance off of the x-axis because that's going to completely skew things for you.
3 little dots. What's that?
Therefore.
Therefore.